This video is supported by Roborace, the first AI, autonomous, and electric racing series. Tesla's acquisition of Maxwell Technologies is widely seen as a move to enhance its battery production capability and potentially, after substantial R&D, revolutionizing the battery industry. Personally, although this view is correct, I think it's missing an important recognition for Tesla's capability to think long-term. This investment is much more than simply enhancing Tesla's already leading battery production technique. It recognizes an industry imperative, and frankly, I think Tesla will do really well because of it. So, what is this industry imperative I'm talking about? Here it is. Whatever Tesla makes, a Chinese EV company will produce at a larger quantity, a competitive quality, and a cheaper price. This is the triple threats Chinese manufacturers are posing to the world. Anyone who's used OnePlus smartphone would tell you how impressed they are about this Chinese manufactured product. And anyone who's visited Walmart will tell you the variety of products that are made in China. For the auto industry specifically, China now manufactures 27.8 million cars per year, more than the combined manufacturing capability of the United States, Japan, and India, which is around 26.2 million cars. In terms of electric vehicles, China has accumulative EV sales of 2.2 million, more than the combined sales in the United States, Norway, Japan, the United Kingdom, and France. So China has a strong manufacturing know-how that will enable Chinese EV companies to compete fiercely in the market. This is the industry imperative I'm talking about. No matter how hard Tesla tries, it has to go through an ultimate test that is competition to really succeed. With the Chinese manufacturing capability, it will be hard for Tesla to compete based on price and quantity. Therefore, the best choice for Tesla is to produce better cars that the Chinese manufacturers cannot produce with their existing technology. That's the brilliance behind the Maxwell Technologies investment. But let's go back to the basics and explain why Tesla is building better products with Maxwell. Lithium-ion batteries are widely considered the oil of the 21st century, and the transition from oil to battery is unstoppable. It has to be. With global warming threatening the future of humanity, alternative energy sources and storage devices are the only thing stopping our extinction. Alternative energy sources can come from solar energy, wind energy, or as I explained in a previous video, nuclear fusion energy. But possible storage devices are singular. It has to be lithium-ion batteries. While there are discussions about using different materials, the most promising batteries we built so far is still made out of lithium. The specific materials used can be different, but physics principle behind them is the same. Using cathode, the negative electrode, anode, the positive electrode, and the electrolyte, chemical interactions happen during charge and discharge, which fuels our electric cars and smartphones. During charging, lithium ions flow from the positive electrode to the negative electrode through the electrolyte. Electrons also flow from the positive electrode to the negative electrode, but take the longer path around the outer circuit. The electrons and ions combine at the negative electrode and deposit lithium there. When no more ions will flow, the battery is fully charged and ready to use. During discharging, the ion flows back through the electrolyte from the negative electrode to the positive electrode. Electrons flow from the negative electrode to the positive electrode through the outer circuit, powering your devices. When the ions and electrons combine at the positive electrode, lithium is deposited there. When all the ions have moved back, the battery is fully discharged and needs charging again. Battery design for Tesla is done by Panasonic, and Tesla improves upon this by designing its own battery pack. This is the technique that's related to how batteries are arranged and what kind of thermal control system should be used. Through this, Tesla is able to make one of the world's best car batteries. However, since the physics behind the battery does not change, there is a ceiling to this type of improvement. This is where technologies from Maxwell come in to break the ceiling and fundamentally change the physics behind Tesla batteries. Maxwell broadly offers two potential improvements to Tesla batteries: its ultracapacitor technology and its electrode dry coating technology. Unlike lithium-ion batteries, ultracapacitors consists of two metal plates coated with proprietary carbon materials, and they are then immersed in an electrolyte made of positive and negative ions dissolved in a solvent. During charging, ions from the electrolyte accumulate on the surface of each carbon-coated plate and form an electric field with one positive and one negative electrode. Unlike ultracapacitor, batteries store energy in a chemical reaction. ions are actually inserted into atomic structure of an electrode. In an ultracapacitor situation, the ions simply cling. This is an important distinction because storing energy without chemical reactions allows ultracapacitors to charge and discharge much faster than batteries. And because ultracapacitors don't suffer the wear and tear caused by chemical reactions, they can also last much longer. The downside, of course, is the lack of energy storage capability. Ultracapacitors store only 5% of the energy of comparable lithium-ion batteries. Therefore, a combination of ultracapacitors and lithium-ion batteries should be used. You can think of ultracapacitors as the RAM of the computer. Information is stored mostly in the hard disks, but RAMs are used as a buffer to access information more efficiently. In a similar way, ultracapacitors can serve as the buffer for lithium-ion batteries. It has a much higher life cycle and a much quicker charging time than lithium-ion batteries. Because of the possibly superior battery design, Maxwell technology is important in many use cases. Higher acceleration is the first benefit of using an ultracapacitor. Roborace, the company that's kind enough to support this episode, for example, has already built robocars for its electric racing series. But as all of us know, acceleration is the key to an exhilarating car race, and therefore ultracapacitors technology might be the key to unlock higher acceleration for races in the future. Now that the team at Roborace is planning to build their own batteries for robocar, ultracapacitors technology becomes even more relevant. In the case of Tesla, its Roadster has a 1.9 seconds acceleration to 60 miles per hour, already highest in the industry. Ultracapacitor could make even faster accelerations possible. Another more relevant benefit is the better hill climbing capability. Whenever there are hills, it is very hard for public buses and semi-trucks to climb them and make sharp turns. Bigger vehicles with higher mass have a greater momentum, which makes them harder to stop and harder to accelerate. This means when it's uphill, trucks take a long time to accelerate, and when it's downhill or at turns, trucks take a long time to decelerate, which is the chief cause of many terrible accidents. Ultracapacitor is a suitable technology for those use cases. Furthermore, this technology is also important for lifetime-dependent transportation modes, taxis, buses, trucks. Most of us are not aware of this, but the economics behind buying them is very different comparing to us buying cars. They're treated as depreciating assets. The time of purchase and the number of years they can be used directly impact their lifetime value. Ultracapacitors with a much higher life cycle will give Tesla Semi a greater value at its cost. This is simple to understand. If the choice is between a gasoline semi-truck that costs $300,000 and a Tesla Semi, and both can be used for 10 years, it's a difficult choice and you need to consider the fuel, repairman cost, and so on. But if the choice is between a gasoline semi-truck that costs $300,000 and works for 10 years, and a Tesla Semi that costs $300,000 but has a lifetime of 20 years, the choice becomes very obvious. This is the potential for ultracapacitors. Additionally, another technology that was featured in the acquisition is dry coating technology. It has a possible improvements for the following areas: a significant increase in energy density, increased battery life by 2 times, 16 times production density increase, 10 to 20% cost reduction, and it puts Tesla in a better position to go fully vertical with cell production. This together with ultracapacitor technology are the key for Tesla to compete with its Chinese counterparts. Chinese manufacturers can undercut Tesla with their production capability and cheaper cost, but not with better quality and better technology. While it is to be noted that the Chinese do have its own made-in-China ultracapacitor suppliers, Maxwell is leading the field by a large margin. This is what I admire about Tesla. It is always looking to win the future and not clinging on to its success of the past. More importantly, it is this kind of long-term planning that has and will help Tesla through its difficult times. Lastly, I've mentioned Roborace in the video. It is supporting our episode today, and it is a very interesting business that has emerged because of the advancement in the field of autonomous electric vehicles. In fact, Roborace is the world's first AI driverless electric racing series, a competition for human and machine teams. It is very opportune for me to talk about Roborace today because, as many of you know, the most crucial times during a race is acceleration and deceleration to change tires and refuel. In the electric racing series Roborace is working on, accelerations and decelerations are all done by AI algorithms autonomously. But how fast Robocar can accelerate and decelerate depends heavily on the battery technologies that are used in the car. Ultracapacitor could be a potential game changer for the future, and I'm very happy to hear from my contact that Roborace is building its own batteries right now. Another benefit of ultracapacitor I mentioned in the video is its enhanced hill climbing capability, and Roborace is taking part in the Goodwood Festival of Speed Hill Climb next week. Check it out if you want to see electric racing cars in action. Roborace is partnering with universities, research institutes, and companies to test out all that's related to autonomous driving. This video, for example, is researchers testing out their own AI algorithm at a racetrack in Germany. I'll link more videos like this in the description down below. Be sure to check them out if you care about our autonomous electric future as much as I do. Thanks for watching. I'll see you next time.